No, normally in last class in the same way or only in this class? So I think we have solved only few problems. We'll come back to the problems once we finish the determinants, right? So uh, let us start determinants. Once we finish determinants, then all put together we'll solve the PYQs of mains and few from advanced as well, right? So uh, this is a new chapter, determinants. If you need the definition of determinants, we can say that the sum of the product of the elements of any row along with the corresponding adjoints. Clear? So the definition, if you want to understand further, you should know about minor and cofactor of a element. So as of now, we can see in this way. Matrices and determinants are like interconnected chapters. Determinant of a matrix exists only if it is a square matrix. Determinant for a rectangular matrix does not exist, right? So first one, if A is equals to Aij 1 by 1, maybe I can say A11 or A is a order 1 square matrix, then determinant of a first order square matrix is the element itself. Determinant we will denote with modulus of the matrix, or we will write DET. Det of A or determinant of A is A itself. This determinant of A we will also write as modulus of A. In this chapter we should read as determinant of A is equals to small a. Clear? If it is a 1 by 1 first order square matrix, determinant is the element itself, right? If A is equals to Aij 2 by 2 is a order 2 square matrix, then we can say, right, let us take A is equals to matrix A is A, B, C, D, right? Normally to find the determinant, what actually we do is, you take any row or any column, we can expand using any row or any column, the value of determinant will be same here. I am trying to expand here using row 1, right? So we will write determinant of A is equals to, instead of square bracket, we will write modulus A, B, C, D. This is determinant of a matrix A. In determinant, what we do is, we use this sign, like let me add this one. This is sign matrix. Sign matrix na plus and minus, plus, minus, minus, and plus. Right? So now listen carefully. We are expanding with row 1. So when you are expanding using any row or any column, delete the corresponding row and the corresponding column where A is there. Right? And then D is there, no? You write here determinant of A is equals to A into D, right? And then like next B I should take, right? So if I take B, sign for B is minus here. So you should write maybe this will be plus into minus B into delete row 1 and column 2, the remaining element determinant you should calculate. Since it is only one element, we'll write the element itself. Clear? So this is BC AD minus BC is the determinant. Normally what we say is product of diagonal elements minus product of non-diagonal elements we will call. Clear? Product of principal diagonal elements minus product of non-principal diagonal elements. Maybe if we are taking an example, let's say matrix M is equals to 1, 2, 3, 4. Determinant of matrix M, that is denoted by det of M, is equals to 1 into 4 minus 2 into 3, which will be equals to 4 minus 6 minus 2 here, right? Determinant of a matrix is a scalar quantity, right? I think everybody copied this one. Can I scroll up? Anybody writing that? Right? Now order 3, that is what important one. Not only order 3, for any order, same method we can use, like let's say if A is equals to Aij 3 by 3 is a order 3 square matrix, then in that case, like listen, let us take in general one small example, like maybe not example, in general let us take matrix A is equals to A11 A12 A13 A21 A22 A23 A31 A32 A33. It is third order square matrix. I am finding determinant of this A, that is det A is equals to, right? So like I can pick any column or any row, like again sign matrix I am writing here. For order 3, we will follow the sign matrix. Always plus, minus, plus. Row 1 I started with plus, now it will be minus, plus, minus, and it will be plus, minus, plus. Alternatively, plus and minus will go. Right? So like we are finding determinant of this matrix. Again, like initially we will use row 1. Right? We are trying to expand the determinant. We are trying to calculate using row 1. So like in row 1, first element is A11. Delete row 1, column 1, and then like what you have, take the determinant of that. Right? This is equals to A11 into determinant of A22, A23, A32, and A33. Right? So next element is A12. Consider the element along with the sign. It will be minus A12 into determinant of. After considering the element along with the sign, delete the first row and second column. Consider these four, then a determinant. Clear? This is determinant of A21, A23, and then A31, A33. In the same way, right? Plus A13 into, consider the element along with the sign, deleting row 1, column 3, this 4 you consider determinant for that 4, it will be A21, A22, A31, and A32. Even though the matrix is fourth order or fifth order or sixth order, same way is what we do here. We always take any row or any column to expand it, and while expanding, like deleting the row and column, after that the nth order matrix becomes n minus 1. Calculate determinant of n minus 1 and keep on going. Right? So like now one example we are taking like a small example. Let's say M is equals to matrix M. We are taking 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this matrix M, we need to find the determinant. We are finding anybody writing this part of the slide? If you are writing, please write it. Just I have taken 9 natural numbers in the order 1, 2, 3, 4, 5, 6, 7, 8, 9. We are trying to find determinant of this one. Right? Can I scroll up? No? So like now determinant of M, that is det M is equals to, always remember this is sign matrix plus minus plus minus plus minus plus minus plus. So like row 1 initially we are making that one as a habit using row 1. First row, first column element along with the sign, that is 1 into. After that delete row 1 and column 1. Take the remaining thing as a determinant. This is determinant of 5, 6, 8 and 9. Now this is 2. Consider the element along with the sign in front of it, that is minus 2. Determinant of, like after doing it, remove the row 1 and column 2. You have like 4, 6, 7 and 9. Last again 3 along with the sign, like deleting row 1 and column 3. You have 4, 5, 7 and 8. Calculate it. Once you have a order 2 here, it is easier. For order 2, we will read as a formula. It will be like product between the principal diagonal elements minus product between the non-principal diagonal elements. AD minus BC we will call. This will be 1 into 5 into 9 minus 8 into 6 minus 2 into 4 into 9 minus 7 into 6 plus 3 into 4 into 8 minus 7 into 5. Let us calculate how much is this. We have 5 nines are 45 minus 48 minus 2 into 4 nines are 36 minus 42 plus 3 into 32 minus 35. We have like how much is this? Minus 3 minus 2 into minus 6 plus 3 into minus 3. So we have minus 3 plus 12 minus 9. I think like I have minus 12 plus 12, which is equals to 0. Right? Any doubt in this? Anybody calculated determinant? Are we getting 0 here? Right? So like this is how we calculate determinant of a square matrix, maybe order 1, maybe order 2. Like determinant of a matrix is a scalar quantity. It may be 0, it may be positive, it may be negative, it can be complex as well. Depends on the matrix. Clear? Understood? If you are learning determinant newly, I'm talking with you only. Remaining guys would have learned in school only. Right? So like now write these 2 points here. Point number 1, determinant of a matrix is a scalar quantity. Second one, determinant is defined only for square matrices. Determinant is not defined for rectangular matrices. Right? Let us learn some basic properties for determinant or like properties of determinant. I suggest the students who already studied in school also please do listen. I don't think this you would have learned in school. In recent rationalization, this was deleted. I don't know. Right? Properties of determinants. Right? Using this property, always we won't expand the determinant and calculate the value. In some cases, we will use the properties of determinant to find the value of determinant. Clear? Right? So anything understood about determinant? Then please put one small subheading, properties of determinant. So properties of determinants, we are seeing first property here. For a square matrix A, right? For a square matrix A, the value of determinant of A is equals to the value of determinant of A transpose. Determinant of a matrix won't be affected even though we are taking transpose. This property says determinant of A transpose is equals to determinant of A. If we want a proof like small proof, we can do for a second order square matrix, right? So a small one to justify this statement. Let us take A is equals to A, B, C and D here. Now we can see here determinant of A is equals to AD minus BC. Simultaneously calculating transpose of A. Transpose of A is A, C, B and D. Trying to calculate again determinant of A transpose is equals to AD minus BC. Therefore, determinant of A is equals determinant of A transpose. This is true for all square matrices. Clear? Determinant value remains unchanged even though we take transpose. Clear? That is first property. Understood this property? Any doubt in this? Anybody? Second one, the value of determinant should be multiplied by -1 when we are interchanging any two rows or two columns. We learned in last class, we can interchange two rows and two columns of a matrix. If you do this one, what happens in determinant is like the value of determinant after interchanging rows and columns, we should multiply with -1. Clear? Like let us take again a small example kind of thing. Let us take delta is determinant, that is A, B, C and D. The value of delta is AD minus BC. Now let us apply the transformation, right? What I am doing for delta, column 1 and column 2, we are interchanging. If we interchange column 1 and column 2, let's call delta 1 is the new determinant, that is like B, D, A and C. So this value delta 1 is BC minus AD. So like if you observe carefully, I can write delta 1 is equals minus 1 into AD minus BC, delta 1 is minus B. As I mentioned, once we are interchanging row to any two rows or any two columns, the value of determinant should be multiplied by minus 1. That's what happened here. Any doubt in this? Anybody? Any doubt? Anybody? No doubt? Copy this one, please. Third one, if any row or column are equals to 0, then the value of determinant is equals to 0. If in a determinant, if you have any row or a column which is entirely equals to 0, in that case, the value of determinant will be equals to 0. Anybody copying previous part? So like, let us say delta is equals to 0, 0, 0, A, B, C, D, E, F. Now if we are expanding this one using row 1, I'll get delta is equals 0 into B, C, E, F minus 0 into determinant of A, C, D, F plus 0 into determinant of A, B, D. 0 into a scalar will be again a 0. Delta is equals to 0. Fourth one, we can take out a non-zero common factor from any row or a column. See, like in case of matrices, if you want to take any common factor out, you have to take that factor out from each and every element, right? In determinants, it is not necessary if there is a common factor in row 1 or in row 2 or in row 3, you can take that out. So like, let's say delta is equals to K A1, K B1, K C1, and this will be A2, B2, C2, A3, B3, C3. Let us say something like this. You have K is a common thing in the row 1. I can take that K out. I can say this is K into determinant of A1, B1, C1, A2, B2, C2 and A3, B3, C3. This is property number 4 for determinants. Number 5, if any two rows or columns are proportional, then the value of determinant is 0. So like what this one says, let's say delta is equals A1, B1, C1, A2, B2, C2, K into A3, sorry, K into A2, K into P2, K into C2. We can take out the common factor from row 3. After taking out, we will be having K into A1, B1, C1, A2, B2, C2, again A2, B2, C2. Now row 2 and row 3 are equal. Did I set this one? No, I didn't, I guess. Here, like I can add, next I'll add it, 6, 1. In this case, if I'm expanding here, it will be K is staying out. A1 into determinant of B2, C2 and again B2, C2. Next minus K into B1 into we have A2, C2, B2, sorry, A2, C2 plus K into C1 determinant of A2, B2, A2, B2. So like you try to expand this, you will get 0 in this case, which will be equals to 0. I think like before this we would have written if any two rows or columns of a determinant are identical, that means equal. In that case, we can say then the value of determinant is 0. So like that one only part of property number 5 I solved. Like here same row 2 and row 3 are same. In that case you try to expand, same thing you will get. It should be above and then that is below. I made it reverse. Scroll up. Proportional means their ratios are same. If any two rows or columns having their elements in the same ratio, then the value of determinant must be 0. If any two rows or columns are identical, and again in that case also the value of determinant must be 0. Can I scroll up now? Sainithan is writing, I guess. Right. also true for technical. Sorry? It is also true for two or zero. 2 plus 2. Now, yes. Any matrix here, I am not saying only for 3. I am taking example for 3, but it is 2. You take this one, no? In this determinant, row 1 and row 2 are identical. Determinant will be 0. Maybe you multiply k inside if you want. Proportional in that case also 0. Order doesn't matter. In general, I am telling this. Then, any doubt till now? Right? So, like, now the seventh one. In seventh one, if you are all elements of a row or column is expressed as sum of two or more then the determinant can be expressed as sum of two or more determinants. See, like what actually I mean. Let's say we have delta is equals determinant of true for all order matrices A1 plus lambda 1 in this way. A1 plus alpha, B1 plus beta, C1 plus gamma, and then like A2, B2, C2, A3, B3, C3. So like if few elements or all elements of a row or a column is expressed as sum of two or more elements, maybe like this can be elements or values, whatever it is. In that case, this single determinant can be expressed as two different determinants. Those determinants as like A1, B1, C1, A2, B2, C2, A3, B3, C3 plus determinant of alpha, beta, gamma, A2, B2, C2, A3, B3, C3. See, like I should do one row at a time. Maybe like entire determinant is expressed in this way. I should break row 1 as two parts, and then like again in row 2 if you are making this 2 becomes again 4 and so on, right? Like if you have like gamma, delta and then something else, right? After writing it again you break this one into 2 and this one into 2. That is the actual rule we should follow. All things I cannot do, like let's say 2 or 3 more, like 2 rows are there in this way. I cannot write in 2 different, it becomes 4, right? Like if you have maybe here uh, E2, something like it is there, right? D2, E2, F2 is also there. Now break for row 1. initially, and then again for row 2 from here, you break for row 2, from here, you break for row 2. That is the rule actually we need to do in this. Clear? Copied this one, everybody? So like now the important one, eighth one. The value of determinant remains unchanged after applying the transformations Ri changes Ri plus alpha into Rj, or Ci changes Ci plus beta into Cj. See, like if you are applying an operations like this, I'm scrolling down. You want me to scroll down? I see, like you can apply transformations similar to this. I remember always applying the transformation. If you are making change in ith row should be multiplied with plus one. If you are making ith column, it should be multiplied with plus one. I'll tell here what happens if you are multiplying with something else, right? So like now, let us take delta is equals to a1 B1, C1, A2, B2, C2, A3, B3, C3. So like what is my claim over here? Even though after applying the row operation, R1 changes R1 plus 2 times of R2, the value of determinant remains unchanged. For that, we are applying it, we will be having a1 plus 2a2, b1 plus 2b2, c1 plus 2c2, and then like remaining is a2, b2, c2, a3, b3, c3 we have, right? So now using the seventh property, a row 1, each and every term of row 1 is expressed as sum of two things. Like I can break the single determinant into two different determinants, and I can write this is determinant of a1, b1, c1, a2, b2, c2, a3, b3, c3. Right? Now next you have determinant of 2 times of A2, 2 times of B2, 2 times of C2, A2, B2, C2, A3, B3, C3. So like please observe the second determinant carefully. In second determinant I can say is like row 1 and row 2 are proportional. If two rows of a determinant are proportional, in that case the value of determinant must be 0. I can show that, just take 2 common. After taking 2 common, a row 1 and row 2 are identical. Expand using row 3, you will get 0 there. Clear? So like now this becomes determinant of A1, B1, C1, A2, B2, C2, and we have A3, B3, C3 plus the determinant of this one is 0. I started with the same thing, I ended up with the same here, right? I hope you understood this. Anybody copying this part of, right? So like I have given only two things here. My motto here is to like make sure I'm telling Ri I'm making change. So Ri I should multiply with 1. I should not multiply with something else. I'll tell what happens if I multiply with something else. Can I scroll up? Right? So this part of the slide you guys are writing. Please write. Now this one note. In the same delta, in the same delta, if we are applying a transformation, anything done? So like, let us write in the same thing, R1 changes 2 times of R1 plus R2. Let's see what happens to this if we are writing in this way. Instead of 1, we are multiplying with some other real number. That is 2 in this case. Now, that delta will be equals to delta 1, let us call. After operation, the determinant may be changed. Let us call delta 1 again. Applying this operation, we will get 2 times of A1 plus A2, 2 times of B1 plus B2, 2 times of C1 plus C2. We have A2, B2, C2, A3, B3, C3. So make this one into two different determinants. Determinant 1 is 2 times of A1, 2 times of B1, 2 times of C1, A2, B2, C2, A3, B3, C3 plus determinant of A2, B2, C2, A2, B2, C2, A3, B3, C3. This determinant is 0. The second one, from first determinant, let us take 2 common from the row 1. It is the determinant what we got is 2 times of the actual one. Delta 1 is 2 times of delta. 2 times of delta is what we got. You guys understood this one, right? If I am multiplying other than 1 some other real number, I should multiply the same real number to the determinant. Then only I'll be having it, right? So this is number 8. So number 9, we are putting remaining all together in 9. So like, can I scroll up? Everybody, okay, right. Any doubts is there in this? Complete. So like, if I have two square matrices, in that case, determinant of k into A is equals k power n into determinant of A, where k is a scalar. Determinant of A into B is equals determinant of A into determinant of B. We'll say determinant of matrices is distributive over multiplication. It is not distributive over addition, subtraction. In division also, like matrix division is not there. So we won't say. Like third one, let's say if you have determinant of A power n will be equals to determinant of A power n. N belongs to nature. About inverse, you will learn later. determinant of A inverse is equals determinant of A power minus 1. Let us see anything we missed in this. As far as I remember, right? So now before going into the actual problems, let us learn about determinants of few standard matrices. One small subheading, please, determinant of some standard matrices. Can I scroll up? Determinant of some standard matrices. I'll be back. Starting with triangle matrix. Statement 1 is about triangle matrix. Please write the statement. Determinant of a triangular matrix is product of diagonal elements. Product of principal diagonal elements. Please write the statement. Determinant of a triangular matrix. This can be upper or lower triangular matrix. Is equals to product of principal diagonal elements. What is this? Let us take delta is equals to determinant A, B, C, 0, D, E, 0, 0, F. This is a what triangular matrix, dear students? It is a upper triangular matrix. In this upper triangular matrix, let us say I am trying to find the determinant using column 1 here. If we are trying to expand using column 1, I am giving explanation. I won't write these all things. We will write A into delete the row and the column. We have this matrix, right? Minus 0 into whatever you write, that is 0, plus 0 into whatever you write, it is 0, right? Now the remaining is like A into determinant of B, E, 0 and F minus 0 into determinant of whatever it is doesn't matter plus 0 into whatever it is doesn't matter. At the end it will be equals to 0, right? Now like this matrix again, P into F minus 0 I will get, that will be equals to A, B, F, which are principal diagonal elements product. Same thing we can say for lower triangular matrix as well. Clear? Any doubt in the sign it in? Sorry? Oh, A, sorry. It is D over here. D over here. D E 0F, no? I wrote B. This is product of principal diagonal elements. Clear? So like second thing, determinant of a diagonal matrix is equals to the product of principal diagonal elements. We can take delta is equals to A 0 0 B. It is a diagonal matrix. Determinant of this diagonal matrix, if you are finding, that will be equals to A into B, that is product of diagonal elements. Clear? Right? Third one, determinant of a identity matrix is equals to 1. Determinant of I will be always equals to 1 because it is a diagonal matrix. Product of principal diagonal elements is 1. Determinant of a null matrix is 0. It is square and null both. Next, we have learned 3 matrices now, starting from idempotent. Determinant of a idempotent matrix is 0 or. So how to tell that? We know that idempotent matrix is A square is equals to identity. Oh, sorry, A square is equals to A. Taking determinant on both sides, determinant of A square is equals determinant of A. So using the property of determinant, determinant of A whole square is equals determinant of A. Rearranging this, determinant of A whole square minus determinant of A is equals to 0. Taking determinant of A common, determinant of A into determinant of A minus 1 is 0. That means either determinant of A is 0 or determinant of A is equals to 1. Anybody writing any point? 1, 2, 3, 4? 4 you are writing? Then okay. So determinant of an involuntary matrix is plus minus 1. So involuntary matrix we know A square is equals identity. Taking determinant on both sides, determinant of A square is equals determinant of identity. This is determinant A square is equals to 1. This implies determinant of A is equals plus minus. Can you guys tell me what will be the determinant of nilpotent matrix? Determinant of an nilpotent matrix is always equals to 0. A power n is equals to null. Take determinant on both sides. You will get 0 there. So now, like whoever listening my class, maybe you would have studied about the determinants in school. I am giving you a small statement. Just tell me whether it is true or false. Right? So, like the statement says, every odd order skew symmetric matrix is invertible. I am telling invertible means non-singular. Non-singular na determinant is non-zero. Right? Inverse of a skew symmetric matrix of odd order exists. What you guys can say about this statement? I have a skew symmetric matrix of odd order. What do you guys think? Do you guys think inverse exists? That means I'm asking about determinant. What do you think? Determinant will be zero, non-zero, zero. How justify your answer, please? This is an important one. I'm scrolling up. I think everybody copy till 7. Am I right? So like order 1 it is 0. Then what about order 3? Order 3 also 0. Using that we will tell. See like 8th one, determinant of a skew symmetric matrix of odd order is 0. Like how to prove this? If it is a skew symmetric matrix of odd order, let's say A transpose is equals to minus A and order is equals to odd natural number. Let us take determinant on both sides. Determinant of A transpose is equals to determinant of minus A. Right? In determinants, we learned the first property. Determinant of a matrix is same as determinant of its transpose. Right? So this becomes determinant of A is equals to. Right? Now, like again, another property we have learned, determinant of a scalar into matrix is equals to scalar power n into, that is, minus 1 power n into determinant of A. Since determinant of k into A is equals k power n into determinant of A. I hope everybody understood this point. Now, it is given in the problem, it is odd order matrix. N is odd. If n is odd, we can say determinant of A is minus 1 into determinant of A. Next, we can write 2 times of determinant of A is 0. This implies determinant of A is equals to 0. I can conclude that skew symmetric matrix of odd order are always singular. About symmetric, it can be 0, it can be non-zero as well. I cannot say like this. Understood this one? Any doubt in this? Next is ninth one, determinant of a orthogonal matrix is equals to plus minus 1. Can be plus 1 or it can be minus 1. We know orthogonal matrix is A into A transpose is equals identity matrix. Taking determinant of A into A transpose is equals determinant of identity. This is determinant of A into determinant of A transpose is equals 1. Now we can write this is determinant of A into determinant of A is 1. Determinant of A square is 1. Therefore, determinant of A should be equals plus minus 1. Right? So like I think different types of standard matrices we have seen. I have given the determinant for each and every matrix. Right? Any doubt in this one, anybody? We still have like how we will differentiate it determinant, how we will integrate a determinant, summation on a determinant, factor theorem of a determinant finding. That we will see in next class. For today, we have learned some things, no? We'll try to apply these things to solve the problems. Previous year JEE mains problems, page 85, problem 22. Like that one, I can solve using directly by expanding it. I can also solve by using properties of determinants. Right? So like let me use properties of determinants. Page 85, problem 22. Given details in the problem is let the numbers 2, B, C be in arithmetic progression. 2, B, C are in arithmetic progression. Maybe if required, we can write 2 times of B is equals to 2 plus C. 2 times of middle term is equal sum of first and last term. And they have given a matrix A is equals to 1, 1 and 1, 2 B C, 4 B square C square. See like given thing 2 less than or equals determinant of A less than or equals 16, then we need to find for C. Right? If we need to find for C, let us use the operations, transformations of a matrix or transformations on determinant. Like I'll use this transformations to make the calculations easier. Easier, I mean, if there are two zeros in a row or a column, I can easily expand it and I can get the answer. For that, what we will do is like, we will apply the column operation. We can apply column, we can apply row. There is no restriction in determinant. What I will do, I'll try to make two zeros in the row 1. If I want to make two zeros in the row 1, I will use column operation. I am writing here on determinant I am applying column 1 changes, column 1 minus column 2. At the same time, I am writing column 2 changes, column 2 minus column 3. Clear? See, like if I wrote column 1 change as column 1 minus column 2, next it is not allowed to write column 2 change as column 2 minus column 1. If you do it, you are making like column 1 and column 2 are proportional. Determinant will be always 0. Clear? So like same two things you cannot use, but only one you can use. Making sure column 1 change, so 1 into column 1. Column 2 is changing, so 2 into column 2 here, right? Sorry, 1 into column 2. If I write this is determinant of A is equals to, there is a change in column 1, 1 minus 1, it will be 0. Then it will be 2 minus b. After that it will be 4 minus b square. There is a change in column 2, 1 minus 1, 0. This is b minus c, b square minus c square. Then it is 1 c square. Hope everybody understood this transformation. Next, like column 1 contains the factor 2 minus b, right? Can we say column b contains the factor 2 minus b? This is 2 minus b into 2 plus b. Column 2 contains the factor b minus c, right? Let us take that factors out from column 1 and column 2 respectively. Now the determinant becomes 2 minus b into b minus c into the determinant of 0, 1, 2 plus b, 0, 1, b plus c, 1, c square. I can also use the operations, but like I'm not willing to use it, right? What we will do, we will expand here. We can, if we want, we can do it, but like this is easier only, we will expand. Next, what I should write? I should write using row 1, you expand 0 into whatever it is 0, minus 0 into whatever it is 0. Last is like 1 into, I'm writing 1 into determinant of 1, 1, 2 plus b and b plus c. We know how to calculate order 2, second order determinant. This is 2 minus b and into b minus c. Next, how much is this? B plus c minus 2 minus b, so plus and then minus got cancelled. Now we can say this will be equals to 2 minus b, b minus c and c minus 2. I can solve this one in different ways. Like they are asking the interval for c, so everything like b I can remove it. How to remove b? So like from here we can write that b is equals to c plus 2 divided by 2. Let us substitute here. If we are substituting the value of b here, now the determinant of A is equals to C minus 2. We are not making any change, right? Maybe let us do one thing instead of doing that. Since it is in arithmetic progression, right? B minus, right? 2 minus B is equals to, next it is B minus C is equals to minus D. Common difference, negative. Correct only? No. First term minus second term minus third term. At the same time, I can write, what is one more thing? C minus 2. So like C minus 2 will be equals to 2 times of common difference. Understood this one? Any doubt in this? Now like we can substitute the determinant of A will be equals to minus d into, next again minus d into, next it will be 2d. So how much is this? 2 into d cube. So now writing it, 2 less than or equals 2 into d cube is less than or equals 60. 1 less than or equals d cube is less than or equals 8. 1 less than or equals d less than or equals 2. Now C means what we can say, C is the third term. C is equals to first term plus 2 times of common difference. For that multiplying 2, 2 less than or equals 2D less than or equals 4. Adding 2 on both sides. 4 less than or equals 2 plus 2D less than or equals 6. So therefore we can write that C belongs to closed bracket 4 to 6 close. Hope everybody understood this. If anybody has any doubt in any part of this problem, please do let me know so that I can clarify your doubt. Not only these two operations, I can also use something else. Whatever you use, the determinant value should be what I wrote here. If you are getting the same value, then you did correct. If the value is different, then you should check the calculation. Any doubt in this, anybody? Any doubt in this, anybody? Online, offline, please do let me know if there is any doubts in this problem. No response will be considered as no doubts. Please copy this one. You
Sir.
can try some problems, but like since I didn't thought much, what I can say is like as of now, you cannot do everything. Maybe try solving matrices problems. Determinants will take some time. Just now we learnt it. Let us solve another few models, then you will understand how things roll out in determinants.
Sir,
Yes, please.
sir, can you explain the right part of the sum, sir?
Right part. This one.
Yes, sir. Yes, sir.
See, like it is given 2 B, C are in arithmetic progression. That means
Okay.
I can write this is 2, 2 plus D, 2 plus 2D. Right? So like now if I am doing like 2 minus B, that is 2 minus B if I am doing A1 minus A2 of a arithmetic progression, I can say that will be equals to A2 minus A3, that will be equals to negative of common difference. This is what I used and I wrote 2 minus B is equals B minus C is equals minus 1 into common difference D, that I substituted. One more thing, C minus D 2. C minus 2 na third term minus first term will be 2 times of common difference. We substituted in the determinant and we got the value of determinant as 2D cube. They have given the interval for determinant A, like I am manipulating, substituting 2D cube in that, and then division by 2, taking cube root on both sides. We got interval for D. If we need interval for C, which is 2 plus 2D, I am manipulating again. Hope you understood now.
Yes, sir.
So like I'll call offline. Aditya K is there offline, online. Your name is there. Please do respond. Aditya K online, offline. Aditya K I cannot see marked absent. R is yes is there online, offline. I cannot see marking offline. Afa is there. Ajay, Josh Andrews absent. Ajit V online I can see. Akhilesh yes, you can go there. Any doubts is there? Want to ask? Then you can go there. Arun Bharati KA. I want to ask like he or she. Hariharan J online. Hari Krishnan I. You can go there. Harish M. Harish Kumar S. Harivarshan S. Divi is there online. Jagdish VR. J.S. Sarvanan. You can go there. Jeevataran. You can go there. Joshia Moses. Karun is also not there. Kirtishri, I can see online. Kirtishri, Loga, Prasanna Ganapati. Lohit is there online, offline. Mithun, you can go here. Mohammed Saifuddin Amir, you can go here. Muthu Selvam T, I will present online. Muthuvel V, please don't use phone in my class. NS Ajay Khanna. That boy is like, what do you say? Sine wave. Up and down is doing from weekend to weekday, weekend to weekday. Naresh Balachandran, you can go here. Padma Vinita V. Pranav Lakshman G. R. Sai Nitin. Ritika T. Roslyn J is present. Yanasri is also present. Shabarinathan K. You can go. Shabari Shviranan. Sai Visagan. Sai Visagan is there online. Can you guys see Sai Visagan here? Santoshni is there online? No. These many absent. Santosh M. Present.
Present, sir.
Gautaman. Not there. Shiva Ganesh M.
Present, sir.
I think you called me yesterday, dear.
Yes, sir.
You can call me today after this class. Shivakumar
Okay.
TS. Shiva Santosh S.